Right, in these notes, we're going to do some stoichiometry. So where we ended last was balancing equations. And so what a balanced equation does, a balanced equation can be interpreted with many different types of quantities, including numbers, atoms, molecules, weight, or even moles. So if you have your balanced equation, don't forget if there's no coefficient, that means that that's a 1. And so how you've been doing it prior for that worksheet, when you would draw out the molecules going in, molecules going out, and count them all up to make sure that what's going in comes out, you thought of it in terms of atoms. So, for example, you would interpret this equation as 2 atoms of magnesium and 1 molecule of oxygen gas make 2 particles of magnesium oxide. So as a chemist in the lab, this is not that helpful since you can't just take 2 atoms of magnesium. You have to deal with a lot of magnesium in order to weigh it out and add it to your reaction, because you can't add any things you can't see. You can't see atoms, you can't see molecules, and you can't see particles. So what you could do is think of this in terms of moles. And so again, it's all color coordinated, so you know where the numbers come from. You can think of it like this: 2 moles of magnesium plus 1 mole of oxygen gas make 2 moles of magnesium oxide. Let's look at another example. So don't forget, there's no coefficient. That means that that's a 1. So I put it there just so you can see where it goes, because it's all color coordinated, so you know exactly where all the numbers are coming from. So the old way you thought of it is 1 molecule of nitrogen and 3 molecules of oxygen gas make 2 molecules of ammonia. So the more helpful way is thinking about large quantities of these atoms, so moles. So 1 mole of nitrogen gas and 3 moles of oxygen gas make 2 moles of ammonia. Let's look at a couple examples. So given the balanced equation below, how many moles of hydrogen gas would be needed to make 1 mole of ammonia? So here's your balanced equation. And so you set this up just like every other problem. You draw a bridge. Your given is 1 mole of ammonia here. You put 1 mole of ammonia in the top left. You put it over 1. And then you look at your balanced equation here. For every 2 moles of ammonia that are produced, you need 3 moles of hydrogen. So the question asks about hydrogen gas. So what you do is you put your 2 moles of ammonia on the bottom, because your given is moles of ammonia, and 3 moles of hydrogen gas on top. So that way moles of ammonia will cancel. You'll be left with moles of hydrogen gas, which is what the question is asking for. And then you just do your math. So you take 3 times 1 is 3, 1 times 2 is 2, 3 divided by 2 is 1.5 moles of hydrogen gas. It just makes sense that you look at your balanced equation. If you want to make half the amount of ammonia, you need to add half the amount of hydrogen gas. All right, example number 2. Given the balanced equation below, how many moles of water are produced when 0.5 moles of oxygen gas are added? So again, you set up bridge, you put your given, you read through your question, it's 0.5 moles of oxygen gas. Include a substance, because you're going to want the moles of that substance to cancel out. You put it over 1. Then you look at your balanced equation. Every 7 moles of oxygen gas that go in, 6 moles of water come out. So you put your 7 moles of oxygen gas on the bottom. Again, color coordinate so you can see where the numbers are coming from. Then you have your 6 moles of water on top. Your moles of O2 go out. They cancel out. And then 0.5 times 6, and 1 times 7. So then it ends up being 3 divided by 7 is 0.4 moles of water are produced. Last question. This one's a little bit more difficult because you're not given moles, and so you have to convert this into moles first before. So you have your 20.1 grams of oxygen asking you how many grams of CO2 are produced. You convert your grams of oxygen into moles, and then you just do what we did on the prior 2 examples. So Start off with the bridge. You put your given 20.1 grams of oxygen on top, put it over 1. Now, you got to convert this into moles, like I just previously mentioned, so you need to calculate the molar mass of oxygen gas. It is 2 oxygens, which are both weigh 16 grams per mole, so that'd be 32 grams for every 1 mole. And so you have to decide what goes on bottom. Again, you want to end up with moles. You want grams to cancel. So you put the grams on the bottom. Again, color coordinate so you can see where it's coming from. That's equivalent to 1 mole of oxygen. These cancel. This will give you moles of oxygen if you were to stop here, but you want to try to find out how many moles of CO2 are produced based upon this initial weight. So you have to continue. So now you use your balanced equation. You go from moles of oxygen to moles of carbon dioxide. So for every 7 moles of oxygen, it produces 4 moles of carbon dioxide. So you can cancel. So if you stopped here, this will give you moles of carbon dioxide. But your answer or your question asks how many grams of carbon dioxide. So you got to go all the way to grams, calculate molar mass of carbon dioxide. 1 carbon, 2 oxygens equals 44.01 grams. And so then you think of what goes on the bottom here. You have your 1 mole of carbon dioxide right here. And that is equal to 44.01 grams of oxygen. These cancel. And then you take 20.1 times 1 times 4 times 44.01. You do the same thing for the bottom. 32 times 7 times 1, and you divide the two, and you end up with 16 grams of carbon dioxide.